Hello everyone, welcome to another video. Today we're going to be talking about solving these one-step equations with decimals. Now you might be thinking to yourself, okay, what's the new content for today? What's the new thing I'm going to be learning? And the reality is that there's really not a new concept that we're going to be going over today. It's not going to be like the last couple of days where we've talked about how to solve one-step equations involving addition, subtraction, multiplication, division. Really what this is going to be is an opportunity for you all to practice solving equations that involve decimals. Basically, how do I do my decimal addition and subtraction? So this is some things that you've probably learned in the past that we're going to try to refresh here, how to do some addition, subtraction, multiplication, division with decimals, okay? So let's look at number one. So in number one here, I have m plus 4.5 equals negative 9.7. So if I'm solving and thinking about my two-step equations I want to solve, what I'm going to be doing is, let me line up my little t-bar I draw here, and I'm going to be subtracting 4.5 from both sides. Now, when I go to add or subtract with decimals, thinking back to when I've learned it before, I want to line up my decimals together, and then I can go ahead and add or subtract them. In this case, we're going to have same signs, add and keep, or both have negatives. So in order for me to solve this, I'm going to be adding these two numbers together. So I'm going to be doing 9.7 plus 4.5. And notice, in this one, it's not as different as it could be, but I do have my decimal points lined up here. So I'll do 7 plus 5, that'll give me 12. And when I add this, when I get to where the decimal is, I put the decimal down here. 9 plus 1 plus 4 is going to be 14, so I get 14.2. So I get that m equals 14.2. Same thing as I've emphasized the last 2 days, every time we solve an equation, we need to make sure we do our check step. We're going to take 14.2 and we're going to plug it in for m over here. So it's going to be 14.2 plus our 4.5, and we need to get that equals negative 9.7. Now, I go to add these together. Wait, hold on. Am I getting negative 9.7? 14.2 plus 4.5, I'm going to get 18.7. Maybe I should go back and check my work and see if I messed something up. Oh, wait, hold on. I go back and see these were two negatives, same signs, add and keep the sign. My answer is actually negative 14.2. I need to make sure I kept that negative. So let's try that. If I do negative 14.2, oh yeah, now when I add them together, I do get negative 9.7. So you can see that it is very, very important that we check our work every time, because it's going to help us catch any silly mistakes we might make, especially including when we have these negatives and we forget to kind of include them. Oh yeah, two negative numbers, add them together, keep that negative sign. I got to remember to do that to get my final answer there, okay? So adding and subtracting with decimals, same process as yesterday. We're just going to have decimals that we have to deal with now when we're solving. All right, next up we have 7.53 equals negative 24.23 plus b. This is one where the variable's now on the right side of our equation. Mr. Guy, does that change what's going on? No, it doesn't at all, okay? Basically, we're still gonna be solving the same way. Still a one-step equation. I look at this and I say, all right, how am I gonna get to 0? How do I get rid of this negative 24.23 that's hanging out with b? Because it's negative and I wanna get to 0, I'm gonna be adding 24.23 to both sides. And again, when I go to add these, I'm going to line up my decimal point so that I can add them together. So here, I need to pay attention and make sure, again, that decimal point's lined up. So if I do 7.53 plus, I need to have 24 point, and notice my decimal points are in the same spot, and then 23. So when I add those together, 3 plus 3 is going to give me 6. 5 plus 2 is 7. The decimal point comes down and stays in the same location. 7 plus 4 will be 11. And then 1 and 2 is 3. So I'll get that 31.76 equals B. And again, I want to go ahead and do that check step. So I want to make sure that 7.53 actually equals negative 24.23 plus, and then we put the 31.76 in for B, 31 0.76. And if you do that addition, you will get 7.53 on the other side. So those are equal, and I'm good to go. Again, same process as yesterday. The only thing different today is that we're looking at what about if I have decimals. Last one with addition and subtraction, one step that we're going to look at. In this one here, all right, I'm trying to get this k by itself. Well, it's k minus 14.4. I have a negative 14.4, so I'm going to be adding 14.4 in order to solve and get the k by itself. Now, when I look over here, again, I want to make sure I think about my rules for when I'm adding and subtracting with negatives. And here I have different signs you subtract. So I want to set up a subtraction problem and then take the sign of the higher number. In this case, that's a negative 18. So I'm going to be doing 18.39 minus, and again, line up the decimal, 14.4. But Mr. Guy, I'm going to the subtraction problem and I have 9 minus and there's nothing here. Well, if there's nothing there, you're going to put a 0 to fill in as a placeholder. 9 minus 0 will give me 9. I'm going to borrow so that I can do the subtraction here. 13 minus 4 is going to be 9. And then again, I keep that decimal. 7 minus 4 is 3, and then the 1 minus 1 is 0. So we're going to get that k equals, I'm not going to make the same mistake as earlier, the sign is the higher AV, in this case the higher absolute value, it was the 18, so we're going to have negative 3.99 as our answer. And again, I'll go ahead and check my work here and make sure that that answer actually works. So that means that we're saying, hey, if I have a negative 3.99 and I subtract 14.4, I should get negative 18.39. And if you do that subtraction, you will get negative 18.39 over here, which means that our check step shows us that our answer was correct, and we actually remembered the negative sign this time, unlike earlier where we missed it. All right? So again, same process as before, only thing new this time is that we're doing it with decimals. All right, so here we're going to be doing some one-step equations involving multiplication and division. So again, we're going to be solving these the same way we solved the problems yesterday when we learned about the one-step equations with multiplication and division, but in this case we have decimals. We have to make sure we know how to multiply and divide with decimals. For number 4 here, I'm going to go ahead and solve for m. M's being multiplied by 0.9, so I'm going to divide both sides by 0.9. Now, you might be asking, Mr. Guy, how do I divide negative 5.4 by 0.9? Well, what you want to do is you want to multiply each number by 10 until you're dividing by a whole number. So in this case, I'm going to multiply each one by 10 once because then I'll be dividing by a whole number. So I'm really going to have negative 54 divided by 9. Okay, negative 54 divided by 9. Now that I'm dividing by a whole number, I'll go ahead and do this division, and then I have to line up my decimal point if I end up with a decimal answer, okay? In this case, we're actually not going to end up with a decimal answer. We're going to get negative 6 as our answer, right? 54 divided by 9 is 6, and we keep the negative around. So m equals negative 6. All right, so I'm good to go. I'm ready to go. Oh, wait, I almost forgot. I got to make sure I do my check step. So we're going to do 0.9 times negative 6 and make sure that that actually gives me negative 5.4. And if I go ahead and check that, I will see that that does, in fact, give me negative 5.4. So we did a good job. That's going to work out. That's going to check out for us. We got the correct answer. All right, let's look at another one that involves a division. All right, so in this case, we're while solving for y, we see we have negative 0.3 times y. We got to get rid of that. What's the opposite of multiplying? It's dividing. So we're going to divide both sides by negative 0.3. So divide here, and I'll be dividing here. All right. Again, I'm going to multiply each by a power of 10, or multiply each by 10 until I'm dividing by a whole number. In this case, I'm going to have 75.4 0.3, and I'm going to be dividing 3 into it, because if I multiply each one by 10, 75.3 and 3. And then we just go ahead and we do division. We line up that decimal place to tell us where the decimal is going to be. 3 goes into 7 2 times, so 7 minus 6. I end up with 1. I bring down a 5. 3 goes into 15 5 times. It's going to equal 15. I subtract. I get 0. I bring down to 3. 3 goes into 3 1 time. 3, subtract, I get 0, okay? And then where does my decimal place go? Well, there was 1 decimal place here, so I'm going to have 1 decimal place here. So 25.1 equals y. But wait, let me make sure I'm paying attention to my sign. It's a positive being divided by a negative, so my answer is going to be negative 25.1. Well, let's check it. Let's make sure it works. So 7.53 needs to equal negative 0.3 times 25.1. Negative 25.1 doesn't help if we don't put in the right number, right? And if we do that check step, we will get 7.53 on both sides. So our answer is good, and we're good to go. Check it off. Look at that. We're good. All right. Last one we're going to look at today before I let you all go try some of your practice is to go ahead and solve one that involves we have division going on, and so we're going to multiply to get that variable by itself. So I'm going to be multiplying both sides by negative 7.2. Okay, so over here, I'm going to multiply by negative 7.2. Sorry, my computer's freaking out for a second here. And then over here, I'm also going to be multiplying by negative 7.2. Okay, so m is going to equal negative 12.5 times negative 7.2. Well, let's kind of see how that looks. So I'm going to set up a division or a multiplication problem just like I would normally. So we're going to do 12.2 times 7.2 and go ahead and do a multiplication. So let's see, 5 times 2, that's 10. 2 times 2, that's 4, and 1 is 5. 1 times 2, that's 2. We put the 0 down here. 7 times 5 is 35, so 5, put a 3. Okay, 2 times 7 is 14, and 3 is 17. And then 1 times 7 is 7, plus 1 is 8. All right, and now we'll go ahead and we'll add these together. So 0 and 0 is 0. 5 and 5 is going to be 10. Here we're going to have 1, 2, and 7, which will be 10 again. And then 1 plus 8 is 9. Now you may be saying, Mr. Guy, my answer is 9,000. I don't know if that seems right. And that's something you want to think about to make sure you're not messing up your decimals is, well, if I do 7.2 times 12.5, should I really be getting 9,000? That seems really big. And that's where we need to go back and actually add in the decimal place. Basically, count how many things are behind decimal points. Let's see, I have 1, 2 numbers that are behind decimal points. That means that my decimal point is going to go 1, 2, and that's where my decimal place is going to be. So my actual answer is that m equals 90. And once again, I want to go ahead and make sure I'm double checking my signs. I had a negative 12.5 times a negative 7.2, so I should be getting a positive answer, in this case positive 90. And we can check it. 90 divided by negative 7.2 needs to equal that negative 12.5. And if I go ahead and do that division, I will get that that's negative 12.5. In addition to what we just went over here, there is also a reference sheet that will be listed for you guys to look at. So if you have any more questions or some concerns about, well, how do I add, subtract, multiply, and divide with decimals, please go ahead and take a look at that reference sheet. That will be a good kind of resource for you all to use while you're working through some of your practice problems, okay? But again, what we did today, same process as yesterday. The only thing that's new and different is something you've actually done before, which is how do I add, subtract, multiply, and divide decimals, okay? In this case, when we're doing one-step equations. Thank you all for watching.